And we are now recording, so let's get on with it then. Nice. So as I said, good morning year 9, and I think every webinar that you should probably have a pen and paper or a pencil ready. I know lots of you do, so if you do, great. If you don't, bring one. Remember at the end to re-watch the webinar, and or simultaneously you can look at the slides as well. It will help you just to be reminded of what we need to do. Right, so this morning we're looking at ionic bonding, and I will keep saying this over and over again. We don't try and trick you in science. So ionic bonding is to do with the joining together of ions. Okay, so we'll find out a lot about what that is shortly. So our big question today is, what is ionic bonding? And just while we're waiting for a moment, let's get you thinking. I want you to think about the word equations for the following 3 reactions. Now, they're common things that you use. They're in the groups that we've been talking about. And they're things that should be familiar to you. If you want a bit of extra challenge, see if you can write the balanced word equation as well. So I'll give you just a moment or two to consider those. Once you've considered those, have a little look at the picture there of a magnesium atom and a magnesium ion, and see if you can think about what's being shown there. What's it telling you? What's happening? And so forth. What are the differences between that atom and ion? What do all these little plus symbols and numbers and letters mean? So have a little think about that. I'll give you a moment more. And so if you want to butt in at any time, that's fine. If there's any questions from the students and so forth, if they come back with a great answer, that'd be marvelous as well.
Cool, will do. Nice one.
So I think we will go through the answers now for the word equation. So you've got potassium reacting with oxygen. So remember, word equations simply are just that. They're the words. They're the little recipe there of what's going in. So our reactants are potassium and oxygen, and we want to know what the products are. In the second one, we've got fluorine and potassium chloride reacting together. There are reactants. Then we've got sodium reacting with water. They are reactants. And what comes out at the end are our products, just a reminder. So for potassium plus oxygen, you get potassium oxide. Fluorine plus potassium chloride, you get potassium fluoride and chlorine. Don't forget about what Sir was saying with those group 7 displacements as well, okay? That fluorine and chlorine and chlorine are in the same group. They're in group 7 as well. So it's about the reactivity. And then you've got sodium plus water, which was another reaction we showed you, that group 1 with water. You're always going to get these hydroxides and hydrogen gas. Just to remind you, or if you want to pop actually, and Sir can get back to me, what's the test for hydrogen gas and what colour would we see our water go with sodium hydroxide in it if we'd added a universal indicator? So I'll let them churn away with the answers to those questions, Sarah, and if you give me the first 2 people to get some answers, that'd be great.
Sounds
and
good.
Then here we've just balanced these out here. What goes in this side must come out this side in terms of the amount of reacting atoms that we have. So even if you struggle with this, by kind of doing trial and error, counting up what's on each side, making sure that you have the same on the other side. I've missed a bit off here, nothing important at this stage, but I haven't put the state symbols just here. So remember that the state symbols here tell us whether they're a solid, liquid or gas or a solution, okay? So we will now have a quick chat about this. If you remember, if you wanted to say anything about what I asked about the colour of universal indicator for our sodium hydroxide, that would be great. And what was the test for hydrogen gas? You can put that into the Q&A and Sarah will get back to me.
Yeah, we've got an answer for that one, Miss.
Oh, brilliant.
Maya. She's come in with the squeaky pop test.
Oh, fantastic. So Maya,
given a sort of a summary of what it is by saying a burnt splint test for hydrogen gas. So stating what it is roughly. Yeah, lovely answer. Good stuff.
Yeah, so you put your lip splint into your test tube where the gas is, and you get a squeaky pop sound. And you should all remember doing that. Okay, fantastic. So looking at our image here then, and I know I'm spending quite a lot of time on this slide, but I think if we talk about this, the rest will be much easier. So here you've got a really standard magnesium atom. There shouldn't be any surprises there for what this shows. We've got 2 electrons on the inner shell, 8 on the second shell, and you've then got 2 on this third shell here. And that will tell you that it's in group 2. There are 2 electrons in the outermost shell, and the period tells us how many electron shells there are as well. Okay. Now we talked about ions being when an atom lost or gained electrons, and this is what a magnesium ion is written like. You'll notice we put these brackets around, and then we've only got 2 electrons in the first shell, and we've got 8 in the outer shell. Now this is because all atoms want the stable structure of a noble gas, and this is what's happened here. And because it's lost 2 electrons, it's become a 2+, okay, because it's got 2 more protons than electrons. And so we say that it's a magnesium. 2+ means it's lost 2 electrons and its charge is 2. Okay, so this charge idea is really important when we're talking about this big question as to what is ionic bonding. So what are we doing today? So we're explaining how ions are formed and comparing them to an atom. We've already started to do that, so that's a great job. We're going to explain that metal atoms lose electrons to become positively charged ions, and non-metals do the opposite. They gain electrons to become negatively charged. Now, this is a really key piece of information. This is directly from AQA, so it's directly from the exam board. You're going to identify the ions formed by the group that they're in. So what charge ions we have in group 1 and group 2 and group 7 and so forth in group 6. The ones we're focusing on and the ones that the exam board ask us to focus on are 1, 2, 6 and 7. And you're going to use dot and cross diagrams to show bonding between these groups. So I think I've already actually covered that in the beginning bit, so I'm going to move on from here. Just highlight, here's your sodium atom, here's your sodium ion. So you can look, again, it's got a charge. And I'll just remind you here, there's no number here, there's just a plus, which means it's only lost 1 electron. So you don't have to put 1+, you can just put plus when there's only 1 electron lost, and the opposite gained here with the chlorine here. It's gained 1 electron, so we just put minus. You don't need to put 1+. You're not going to get marked wrong, but you don't need to do it. So electrons, as we know, have a negative charge, and atoms have no overall charge. Now, just always think just a little bit before you launch into answering anything. The reason atoms have no overall charge, and if we think about this from a logical point of view, is because they have the same amount of protons as they do electrons, which means that they've got the same amount of positive as they do negative. So it means they're neutral, they've got no charge. And the other thing that's neutral within the atom are neutrons. And they're not actually involved in our bonding at all because they don't have any charges like the electrons and protons. So what happens if an atom loses or picks up 1 or more electrons? Well, you get an ion, okay? And the electrons come from other atoms. So some common ions here. The one that you will always remember are your sodium and your chlorine, because they make sodium chloride when they're together. They're ionically bonded, and they're what you sprinkle on your chips or add to your spaghetti. I don't know. So it's also, sodium chloride is table salt. And if you remember that when you have a group 1 react with a group 7, you can start to see how it all starts to link together. Salts are formed. Okay, so it's a really important thing to remember. So you've got a group 1 with a group 7 here, okay, that they can bond together. And we've got a magnesium ion here. Notice we do put the number here because it's 2, okay. So a magnesium ion is in group 2. It's got 2 electrons in the outer shell, a magnesium atom rather, and it forms a magnesium ion 2+, okay. And calcium is in group 2 as well. We can see that because it's got 2 electrons in the outer shell, and it also forms a 2+ ion, okay. It's because it's lost 2 electrons. So these are some of our common ions, and this tells us here how many electrons are in each shell. And whenever you're drawing these, especially in exams, if you make an error, which I'm not going to lie, doing lots of dots and crosses, you can make errors. If you've written this correctly, the exam board can see that you know what you're talking about. You know that there should be 2 in the first shell, 8 in the second, 8 in the third, and 2 in the fourth shell, but that you've just made a mistake with your dot and cross. They can actually go, oh, actually, let's have a look at awarding some marks here because it's been a slip up. So be really, really precise about what you do. Write down all of the information that is necessary. Okay. So why do metals and non-metals form ions when they react to form compounds? Well, we'll go back to thinking about our structure of the atom. Remember, we've got these two things here are what's important when we're talking about ionic bonding. We're talking about the positive charge of a proton and the negative charge of electrons. And I think now we can introduce this idea that if you put a positive and a negative together, they attract. Okay, so they attract. So these opposite charges attract. And that's something to keep in the back of your mind that's really key. So when we have an atomic number, that tells us the number of protons. And if you think back to the periodic table, it refers to atomic number and proton number. I can't remember which one, but they put one in brackets. And that's the number of protons in each atom of an element. This number doesn't change, otherwise it wouldn't be that element anymore. So the number of protons has to remain the same when we're talking about bonding. But what happens is the number of electrons changes, and that's where the charge occurs. In an atom, we have this equal number of protons and electrons, and that's why they're neutral. When we start to move the electrons around, they gain a charge because that balance is no more, if you think about those scales again. So we know an ion is a charged particle. When atoms lose or gain electrons, they form ions, and that's why we call it ionic bonding, because what these ions do is those charges are attracted to each other, these really strong electrostatic forces holding them together. Notice here we've got sodium and chlorine, equal number but opposite charges. They're like hello, and they fall in love and bond together. If you want to think of it like that, it's these charges attracting each other. So key ideas. When a metal atom reacts with a non-metal atom, atoms in the outer shell of our metal are transferred. Metals lose electrons to become positively charged ions. Non-metal atoms gain electrons to become negatively charged ions. This will all be here for you to refer back to. So we'll have a quick look at sodium here, just as an example. Let me just quickly time check. Yes. So a sodium atom has 11 protons and 11 electrons and protons. They're equal, they're balanced, it's neutral, no charge. Now, as I said before, all of these atoms want to have a stable structure like those of the noble gases. That means they have a full outer shell. There's an error in there, but there's an extra electron coming from somewhere. Oh no, it's shifted from here. So it's actually in group 1, so the electron configuration is 281, okay? What happens is the sodium ion still has 11 protons in its nucleus, but it only has 10 electrons. And so it's become positive 1 charge because the 11 minus the 10 is 1. And you get Na plus, and the structure is now 2 and 8. Excuse that error. So calcium atom has 20 protons and 20 electrons, balanced, neutral. It needs to lose 2 electrons to get that full outer shell, similar to that of the noble gases. So if you have a look here, 2882, group 2 calcium atom. When it loses those 2 electrons, it's the metal, so it becomes positively charged. We get 288 and a charge of 2 plus. Always making sure you put the brackets to indicate that it's an ion. Still got 20 protons in the nucleus, so it's still a calcium. Okay, remember that proton number is almost like its ID number. If it's got 20 protons in its nucleus, it's calcium. It can't be anything else. It must be calcium. But it could be an ion if it was charged because it had lost or gained electrons. So it would be a calcium ion. And again, the 20 positive protons minus the negative electrons, the 2, gives us a 2 plus charge. And the same thing here with chlorine. It's in group 7. It still has 17 protons in its nucleus when it becomes an ion, but it has 18 electrons because it's gained an electron from one of the group 1 elements in this instance. 17, and then you've got your 8 minus 18 is minus 1. Okay, any questions so far, sir?
No, okay. There was a couple of bits of confusion about protons and electrons, but I'm talking to them separately. Otherwise, I think
okay,
we're good.
Thank you. So an oxygen atom has its 8 protons in its nucleus, and it's got 8 electrons in its electron shells. 6 electrons in its electron shell here, and 8 in the first shell, 2 in the first shell, totaling 8. So it's got 8 electrons in total and 8 protons, so it's neutrally charged. Remember, those electrons can be lost. They're what transferred or donated or received. But the fact that it's got 8 protons in its nucleus means it's still an oxygen. So we get an oxide ion. We have gained 2 electrons to fill that outer shell, like the structure of a noble gas. And this time it's a 2- because it's got 2 more electrons, which are negative, compared to its protons. Okay, so it's still got its 8 protons, but it's now got extra electrons. So it's got 10 electrons to its 8 protons. So that proton number doesn't change. It tells us what the atom is. It's its ID number. It's the electron number that can change. So this idea of a perfect match took me a long time to find this picture, but I quite like it. So metal atoms want to lose electrons to have their stable outer shell, like those of a noble gas. Non-metals want to do this to gain them to get that noble gas structure as well. So sodium's desperate to lose its electron. It's like, I want to be stable. I'm just personifying these atoms here. And a chlorine atom is desperate to gain an electron. It's like, I want to be stable too. And they look at each other if they were real. And they're like, oh, I'd like that electron. And the sodium says, well, I'd like to give it away, so I'm stable. And the chlorine wants to be stable too. And so they become a perfect match. Sodium in group 1 donates its outer electron, and chlorine in group 7 accepts it, meaning that that now has a full outer shell for our chlorine and for our sodium. Okay, and remember that proton number hasn't changed. There's still sodium ions and chloride ions. The opposite charges of these ions, because we now know that sodium has lost an electron, so it's positively charged just by 1, and chlorine has gained 1 electron, so it's negatively charged by 1. And these opposite charges, these positives and these negatives, are strongly attracted to each other. And that's how they bond together. And we call that ionic bonding. So ionic bonding is where the opposite charges of ions are attracted to each other. And these forces are very strong holding them together. And just to remember, a non-metal and a metal form an ionic bond. So that's a non-metal and a metal. The other types of bonding we will go through involve non-metals and non-metals and metals and metals. But for ionic bonding, it's a non-metal and a metal. So let's have a quick poll. I think I have to stop sharing to do the poll. Let me see, sir. What can you see now?
We can see you.
And a poll?
And we've got the poll in front of us. That's brilliant. Yeah, we've got the quick poll.
Brilliant. So, lovely young people, have a little go. Have a go at answering these. We'll give you 2 minutes to have a go and let's see what happens. Be confident. Remember, there's no problem in making mistakes, because then we know what to go over again and what you're not sure about as well. So we've got the voting has begun. We are off the starting blocks. So really have a go here. So far, everyone's remembered my last statement about which type of elements are involved in ionic bonding. And actually, that's massively crucial. If you get the bonding wrong, you'll lose the entire marks in exams because you're selecting the wrong type of bond. So the fact that you're able to say a metal and a non-metal is brilliant. So we're having a look at, while you're doing it, I'm going to give you some help. So what charge does an atom have? Now, we talked about there being an equal number of protons and an equal number of electrons. So think about that. If there's an equal number on a balance, on a scale, it doesn't shift, okay? So you've got equal number of positive and equal number of negative. And if those are our charged particles and they cancel each other out, what charge does an atom have? Does it have a charge? Fantastic. 100% of you have got the elements involved in ionic bonding. Group 2 elements have when they form ions. Good, well done. Most of you got that right. How many electrons would oxygen gain to become an ion? Fantastic. Remember the group that it's in. What group is oxygen in? It's in group 6. I'll give you that hint. Which of these have ionic bonds? Oh, this is interesting. Having a look here. The fact that all of you said a metal, and well, nearly all of you, a metal and a non-metal form ionic bonds, which is correct, then you need to be thinking here, which of these are a metal plus a non-metal for your answer. So 77% of you have selected potassium chloride. You're absolutely right, because you've got potassium in group 1 and chlorine in group 7. Now, think about this. Is hydrogen a metal? Actually, hydrogen is a bit of a tricky one. We can talk about that a bit later. In this instance, that's a covalent bond, but we'll come to that later. Carbon dioxide, carbon, non-metal, and I've made a mistake there. It should be carbon dioxide, not diodide. So it's carbon dioxide. So you've got a carbon and oxygen. Are they a metal and a non-metal, which is what you've told me? So in ionic bonds, it's metals plus non-metals. You're able to tell us that statement, but not quite identify the metals and the non-metals there. So we'll go up a little bit, see how we're going. Still some of you are answering. We've had an extra minute of this, so I think we'll end it there. So you're right. Majority of you, atoms have no charge. They're neutral because they have equal numbers of positives and negatives. Which type of elements are involved in ionic bonding? Of the answers, 98% of you said a metal and a non-metal. You're absolutely right. Here, 73% of you have said 2+ for the group 2 elements when they form ions. Yes. How many electrons would oxygen gain to become an ion? 2. Oh, actually, hang on. I said to gain. I made a mistake there. 2+. So what charge do group 2 elements have when they form ions? That's correct. Okay, no, that is right. And how many electrons would oxygen gain to become an ion? Absolutely. And then you guys have been able to identify lots of these, but just remember which of these elements are metals and which are non-metals. And those are the ones that are coming together to form those ionic bonds. So thank you very much, year 9. I'm now going to close that. And sir, are you back on my screen again?
Yep, yes we are.
Fantastic. And we can now see my dot and cross diagram.
Exactly, yeah, perfect.
Brilliant. So here we have dots and crosses. When we're drawing ions, we use dots and crosses. And sometimes I've had students go, well, why can't we just use the crosses? Now, the problem is we want to show the transfer of one electron to another ion. So if we did them all in crosses, we wouldn't know which one had moved, is essentially it. So if you see the outer shell electron on our sodium, when it joins our chlorine, we can see very obviously that it's come from another atom or another ion in this case. So that's why we use dots and crosses, just so we can see the difference and see where they move from. So I thought what we'd do is we would have a go. I'll just do one with you, actually. Let's see how this works. I said to Sarah I was going to try this out and see if it worked. So let's see if it does. Oh, let's go back. So here we've got a sodium. Now, a sodium atom is 2. Let's just, oh, look. So I don't know if it is going to work. It's 2.
Yeah, it's working. Looks great.
Oh, yeah, brilliant.
Yeah.
So I'm only going to show the outer shell. Otherwise, we'll be here all year. So, but what you must do, as I said, is show what's in each shell. So in sodium, we've got 2 electrons in the innermost shell, then 8, then 1. We know it's in group 1 because it's got that. Now, chlorine is in group 7. So we're just going to show the outer shell. And notice I'm doing the dots, not the crosses, so we can indicate what is which is which. So chlorine, we know, is in group 7, and it's got 17 protons to identify it, which means it has 17 electrons. So here we have our atoms, sodium, and now we're going to show our ions. So if you have a look here then, if this electron here has been donated, transferred to chlorine, we drop down to the next shell, which means that sodium now has a full outer shell. Now, we need to still identify that that is sodium. So we say that we've got 2 in the first shell and 8 in the second shell. Now, we also need to show that that is an actual ion. So what we do is we put a Na plus. Okay, so that's its notation there. And then a plus like that. And then chlorine, we did dots, so we must be consistent. That's another thing as well. Be really consistent if you're doing these in exams. It's really important. 6 dots. Now we show that sodium has bonded with chlorine and given it its outer shell electron. So now chlorine is 288. Okay, so it's got one more electron than it did prior. So Cl minus. And that is basically how you show that they've bonded together. Now, the reason they've bonded together, we can see really obviously, is this has got one positive and this has got one negative. And those are really, really strong forces that hold them together. They're bonded. And we say it's ionic bonding, it's a chemical bond, and they're very difficult to break. And when we move on to some of the other ionic structures, they're really, really strong. We'll have a look at those. I will just check the time and see if we do one more. I think we'll just have a quick look at one more. So potassium, similarly, we're just going to show the one electron in the outer shell, and that's 281. And then chlorine is again 287, and the 7. And again, sorry about my handwriting. I'll be honest, this is the first time I've used this strange pen contraption in the PowerPoint, but it's very useful. So 288. Well, that's it, 288, and then 288. Right, I should get Sir to check what I'm doing here. Yeah, again,
I'm with you in these.
Positive ion, and this becomes a negative ion, and we show again because it's group 1. With group 2, you would just transfer the 2 electrons to the shell. And some of you might ask, why am I doing it in pairs? Well, it's much less easier to make mistakes. If you put the dots and the crosses all around the shells without doing them in pairs, it can be a little bit more tricky. Okay, it's just, you won't get marked wrong or anything like that in an exam. It's just, it makes it easier for the examiner, and you want the examiner to be happy if you do it in pairs. And it's much easier for you to then count up and check that you have done them correctly. So brilliant stuff. Let's move on. Let's close this eye and move on. So here is an exam question, and it is an oxygen and a calcium. So the first thing you do is have a look at the picture. The figure below shows the electronic structure of an oxygen atom and a calcium atom. And I've put here some of the language that I would suggest you considered. Okay, so think about, well, that's scientific language. We look at it, we've got a non-metal in group 6 and a metal from group 2. So immediately, you've all told me that a metal and a non-metal is ionic bonding. So you know straight away, right, you've got ionic bonding. So you're already onto a winner there. And then it says here, describe how the calcium atom and the oxygen atom form calcium oxide. So they've given you lots of information here, and you should also give the charge each ion forms. So basically the information that you need here, I've done this so that I have to write on it, is that we're going to form an ionic bond. So let's try that. So oxygen will gain 2 electrons. Yeah. And then you'd say to form the ion that it's going to form, which is O2 minus. Yeah. And then you would say that the calcium transfers, look at that language that we're using, it's outer electrons to oxygen, and it would form Ca2+ ion. And then what you do is say the opposite charges, if you like, attract the ions together. Strong, and I'd always put this in, electrostatic forces hold our ions together, and that's showing making calcium oxide. Right, any questions? I think for the questions next week I'm going to pre-type them. Right, so any questions?
Just quickly, Miss, would it be all right to say the calcium loses its outer electrons?
Absolutely, yes. Yep. So as long as you are saying that the calcium loses its electrons and the oxygen gets them, that's absolutely fine. Although the loss and gain are totally acceptable words to use, as well as the transfer or donates, you can use those as well. But as long as it's saying what's happening, that's fine. Yeah. Although I've used that language.
That's good. It's just they might see a very similar question appearing in their Google Forms this week. So just wanted to clarify the language quickly.
Yeah, no, that's absolutely fine. Brilliant. The loss and gain is absolutely fine as well.
Nice one. Lovely stuff.
Brilliant. Thank you. So let's move on then. I think we are almost done here. And just a very quick challenge for you, back to this recognizing ionic bonds. I won't go through them all. Here, I'll give you a hint, go on, because I'm kind. Metals plus non-metals give you ionic bonds. Okay, so you would have your periodic table in front of you. Always have your periodic table. Sarah and I have told you, it is so important. If you're uncertain about anything, refer to it, because you know all the elements in group 1 are metals. You know in group 2 you've got your alkali earth metals. You know group 7 are halogens and non-metals, and group Z, you know all of these things, that you know the periodic table, so use it. We don't expect you to know all of the elements and what group they're in, but if you know where to find them and what those groups are, then you're able to look at these things and answer really easily. So potassium, metal; iodine, non-metal; potassium iodide, Bob's your uncle. You've got an ionic bond. Look here, you've got your carbon dioxide. We know that carbon is not a metal, and we know that oxygen is not a metal, so that is not an ionic bond. Okay. Methane is actually a combination where you have carbon and hydrogen bonded together, and that again, non-metals, that would not be ionic bonds. Okay, and where we've got kind of metals on their own and things like that, I didn't do any of those on their own actually. Yeah, aluminium and things like that. No, okay, so they're not ionic bonds. Just really to remind you of some of the language, once you've looked at this as well, I think it would be quite a good idea, and actually Sarah and I might do a starter next week on this, just about the differences between compounds, mixtures and molecules. That's one of the ones that you guys get confused on as well, so I think we could shove that into our starter next week as well. And I think that's that really. We've explained how ions are formed. You can look at this, we'll share the slides with you. Explain how ions are formed and compare them to an atom. We've done that. Explain that metals lose and non-metals gain, and the ions that they create. We've done that. Identify the ions formed by the group that the metal and non-metal are in, group 1. So you've got things like your potassium. They're going to form +1 because they're in group 1. Group 2 is going to lose 2, so it's going to form a 2+ ion. And so conversely, group 6 are going to gain 2, so they're going to be 2-, and group 7 are going to gain 1, and so that they will be, did I say gain? Group 7 are going to gain, so they'll be a-. Okay, so your metals are your pluses, and your non-metals there are your minuses. You are going to be able to use dot and cross diagrams to show the bonding between metals in groups 1 and 2. So You have tasks to do on all of these things. If your teacher sets you the dot and cross diagrams, I would suggest that you either printed it and did it by hand and then took a picture and sent it, or if you are incredibly wonderful at computing and technology, by all means, write onto it using whatever program you wish. I think it's a Word document, so you can.
So I'm just thinking about that, Miss. If it's a Word document, that would be quite good, because then they can obviously just add shapes and stuff on the Google Doc. Or if not, they can print screen, open it in Paint, and then just draw on it as well.
Oh, I like that idea, sir. That's good. Print screen it and then put it into a graphics program. And I think that would be the easiest as well.
Yeah, it might be.
That's what I would choose, but it's up to you guys. So we are going to let you go off now, and let me stop sharing my screen. And have we got any questions before we end today?
Most of them have sort of been, actually, there's been a bit of worry about their understanding, just in terms of atoms and things. And I was suggesting a couple of times that perhaps if they spend, half an hour going over previous webinars, that can be really useful, or just emailing and getting in contact with your teachers, because they'll be able to give you more direct feedback, guys, to try and help you get over that little bump. But there's no direct questions about the ionic bonding today.
I mean, guys, it is challenging, and it's just really practicing when it comes to atoms and ions and thinking about the difference. And definitely on the slides that we give you, I think there's a couple of web pages, I think. If not, talk to your teachers, and BBC Bite Size is really good, and just practice and read. And like I said, we've given you some sheets to have a practice, and don't worry about making mistakes. We just need to get you thinking about all these things now. Right, okay, we will see you next week.
Lovely stuff. Thank you, Miss.
Bye, thanks, Dad.
Cheers, bye.
Bye.